Hi, this is my third video in the Introduction to Calculus, and we're now, having completed what calculus is and what it actually does, we're now ready to start doing some actual differentiation. Right, a reminder of what we're going to do. We're going to be starting off with an equation of a curve. It will be y equals something. And then we're going to differentiate that equation, and we're going to create the gradient equation. Once we've got that gradient equation, then we can put numbers into it to find particular gradients at any point on the curve. Let's imagine we start off with an equation. And let's say y equals 3x squared minus 4x. Now that is not a straight line, that is a curve. You could plot it if you wanted to. We're not even going to bother plotting it. We're just going to differentiate it. That means we're going to change it into dy by dx. And that will give us the gradient equation. Now there's a special way of doing that, and I'm not going to show you quite yet how you do it, but that is what it becomes. So the gradient equation is 6x minus 4, or dy by dx is 6x minus 4. Now once we've got that equation, we can put any value of x into that equation and it will give us the gradient. If we put a value of x into the top equation, it will give us the y value. But if we put an x value into the second equation, that dy by dx equation, that will give us the gradient equation. So for example, if we wanted to find the gradient when x equals 3, we could put 3 into the dy by dx equation, and that will give us 6 times 3 minus 4, which gives us 14. So what we found here is if you have a graph of y equals 3x squared minus 4x, we can find the gradient at any point on that graph because we found the gradient equation and then put a number in for that. Let's have a few look at examples of some straight lines, because you can also differentiate straight lines, and if you do that you will get a fixed number. So here's the first equation. Y equals 8. Now, if I said what's the gradient equation, or what's the gradient of that line, you could tell me straight away the gradient of that line is 0. In other words, dy by dx for that equation is 0. If I have a different equation, let's have this one, which is y equals minus 5. What's the gradient of that equation? Well, dy by dx of that is also 0. It's a fixed number. It doesn't change anywhere along its length. If I have this equation, this is y equals x. What's the gradient of that equation? Well, you probably know that the gradient of that equation is 1. So dy by dx of this equation will be 1. Here's another equation. This is y equals 3x. If you remember y equals mx plus c, m is the gradient. In this case, it's 3. So dy by dx equals 3. Okay, here's another one. This is y equals 2x minus 10. Remember, y equals mx plus c, the gradient of this equation must be 2 along its whole length. So dy by dx is 2. A couple more. This is y equals a half x plus 4. The gradient of this one is a half. Dy by dx equals half. And the gradient of this last one, y equals 5 minus x, a little bit harder, but the gradient of this one is minus 1. Okay, now this isn't proper differentiation. This is just finding the gradients of a few straight lines, which is relatively easy. But there is a pattern, and you might start to recognize what the pattern is. If we look down that table of equations and derivatives, it looks like the number on its own doesn't really matter. The y equals 8 doesn't make any difference to what the derivative is still 0. When y is minus 5, the derivative is still 0. It's only the number in front of the x that matters. So when y equals x, we have a 1x, so therefore the gradient is 1. When y equals 3x, the gradient is 3. When y is 2x, the gradient is 2. When y equals a half x, the gradient is a half. The 4 didn't matter. The minus 10 didn't matter. And when you've got y equals 5 minus x, the gradient is minus 1. The number didn't matter. It's how many x's that matter. And that's one clue as to how we're going to differentiate things. One of the things is we look for the number in front of the x, and that will become part of our answer. Right, so now I'm going to show you how you actually differentiate an equation. Here's our equation. It's quite a complicated equation, as you can see, because it has x to the power of 4 in it. So this graph will actually go up and down 4 times. But we don't actually need to know what it looks like to be able to find the gradient at every point. We're not going to draw a graph. We're just going to follow a special rule. We're going to look at the original equation, and then we're going to work through each term with this special rule. So for each term, we have to multiply the power of x, so the first term, that's 4, by the number in front, which is 7. And that will become the new number in front. So the new number in front of that term is going to be 28. But we also have to reduce the power by 1. So the power of x will change from x to the power of 4 to x to the power of 3. And we work our way along with that rule for each term. So let's remember the rule again. We take each term and we multiply the power of x, 4, by the number in front, the 7, and that becomes the new number in front. And then we reduce the power of x by 1. So let's do that. So first of all, it's dy by dx. This is the gradient equation. This isn't the y equation. We've already got the y equation. This is the gradient equation. So the first term is going to become 4 times 7, which is 28. And then x to the power of 3 rather than x to the power of 4. And we follow it along. So the next one, we multiply the 3 by the 4 to get 12. And then we reduce the 3 by 1 to get 2. So it becomes 12x squared. The next one, we multiply the 2 by the minus 8. That will give us minus 16. And we reduce the power by 1, so it becomes x. So it's minus 16x. The next term, 9x. Now we did one of these just now with straight line graphs, and we realized that the x term just becomes a number. But it does follow the rule. We can say the power of 1 times 9 gives us 9, and we reduce the power by 1, so it becomes 9x to the 0, which is just 9. Probably you won't go through that process. Probably for this one, you'll just change 9x to 9. And if you remember the straight lines, the actual number on its own didn't make any difference to the gradient. So the number in the end just disappears. Now, if you look at each of those terms, you'll notice that x to the power of 4 term, the 7x to the power of 4, that's now become an x to the power of 3 term. It's become a little bit simpler. The second term was x to the power of 3. That's now become x squared. The x squared has become x. The x has become a number, and the number has disappeared. Everything has got slightly simpler. So now we have a rule which helps us to differentiate or find the gradient equation. And that rule can be represented by the equation at the bottom of the screen. It's in red now. So we start off with y equals something x to the something. Could be y equals x 3x cubed. And then we multiply the n by the a to get the number in front, and we reduce the power by 1. And that's shown there in dy by dx equals n times a, x to the power of n minus 1. So here's a few examples. There's y equals x squared. That's what it looks like. So if we differentiate that, we're going to get dy by dx equals, now remember the rule, multiply the power by the number in front. Now the number in front doesn't look like there's anything there, but there must be a 1. So 2 times 1 becomes the number in front, and we reduce the power by 1, so we get dy by dx equals 2x to the power of 1, or just 2x. Here's another equation, y equals x squared minus 7. Now, we take each term, the first one, we multiply the power by the number in front, that's going to become 2, and we reduce the power by 1, so it becomes 2x again. Then we look at the 7, and it's just a number, and numbers just disappear. So the answer is exactly the same as the previous one. And then you think, hang on a minute, those two equations we've just done, they are the same, except one of them is down by 7 compared with the other. One's higher up than the other. But they have the same gradient. That number did not make any difference. Here's another equation. Y equals 2x squared minus 5x minus 3. This is a different shape slightly to the one before. If we differentiate it, we're going to get, multiply the 2 by the 2 to get 4, which is the power by 1. 2 becomes 4x. The minus 5x is going to become minus 5. And the minus 3 is just going to disappear. So we get dy by dx is 4x minus 5. And we can go on and do lots of other ones. So here's another equation. Y equals 10x minus 2x squared. So 10x, we multiply, we can remember this in two ways. You can either remember you multiply the power by the number in front, multiply the power by the number in front, and then reduce the power by 1. Or you can just remember that 10x just becomes 10. The minus 2x squared is going to become minus 4x. So we get 10 minus 4x. Here's another one. Y equals 3x minus a half x squared. A little bit more tricky, this one. The 3x, when you differentiate it, just becomes 3. But the minus a half x squared, we have to multiply the power, 2, by the number in front, which is half. 2 times a half is 1. And then we reduce the power by 1. So the answer is going to be 3x is going to become 3. And the minus a half x squared is going to become minus 1x, or minus x. So the answer is dy by dx equals 3 minus x. Last one. Y equals 0.2x cubed minus 1.5x squared plus 3x minus 4. It's a very complicated one, and you can see the graph. It does look, it's got a bit of a wiggle in there. To differentiate it, we have to multiply the power by the number in front. That becomes 0.6x squared minus 3x plus 3, and the minus 4 just disappears. Okay, so here's just a few more questions on the same kind of lines. This time we haven't got the graphs. We're just going to look at the equation and work out the gradient equation, or the derivative. So first one, y equals 3x squared. Remember the pattern. It's going to become dy by dx is going to become 6x. Next one, y equals 2x to the power of 4 minus 6x squared. So if you follow the pattern, it's going to become 8x cubed minus 12x. Next one, they're getting slightly harder, but in actual fact, they aren't really much harder. 0.4x cubed is going to become 1.2x squared. The 1.2x squared is going to become 2.4x. The minus 7x is going to become 7, and the 4.2 will just disappear. And the last one, this is why you got fractions. This is why we did fractions earlier. 3 times 2/3 is going to become 6/3, which is just 2, so it's 2x squared. The 2 times minus 5 over 4 is going to become minus 10 over 4, which is minus 5 over 2. X. The minus 1/3 x is just going to become minus 1/3, and the 5 over 8 is just going to disappear. So let's summarize everything we've done so far. We start off with y equals something, some curve. Then we differentiate it to find the derivative, dy by dx equals, and then we can put numbers into that to find the gradients. And the rule we've got there at the bottom of the screen. That's it for the moment. And now you need to do some practice.